I'm Chris Narbonese, one of the directors of Ferro Eleganza, and we really do structural steel fabrication and also the erection of that structural steel on site. So Mafube was a very interesting project for us to be involved with because it's a project that the client, they had a building called the EMV building that was standing on a certain site of Mafube's mine. And they were finished mining in that area and they needed to move this whole building to another area. So we had to remove the sheeting of the building and dismantle the structure, move it about 100 kilometers, and then erect the structure again and clad it with the original cladding. They didn't want to put on new cladding or anything like that. So that was really the challenge of this building. But above that, it had to be done in Anglo's highest mine health and safety zone. So you can just imagine how dismantling a building, which is already not a safe process, had to be done within the health and safety of the Mafube and the Anglo mine spec. That building had no workshop drawings. So to dismantle a building and erect a building, you need a technical, detailed, marked up general arrangement how to assemble the building. So we started off by redrawing the building according to what it is there, so that we had drawings and marks to work according to. Then before we started dismantling anything, we marked all the sheeting, we gave it numbers so that they can be put back into exactly the same position, because you can imagine the sheeting is positively fixed, it's IBR sheeting. So when you remove it, it's full of holes where the screws were. And to put them back exactly where they were so that the holes line up, you must reuse the same holes on the same purlins. Obviously you can drill into the purlins, but if the holes are not in the right position, you'll have a roof that's like a sieve and it's going to leak. So we had to mark them clearly to put them back in exactly the same position, roof sheeting and side cladding. Then with cherry pickers, we went through the entire roof structure and literally marked up every single piece of steel according to our Tekla model that we had drawn, so that we knew how to replace the steel when we reassemble it. So the steel had to be dismantled in the opposite sequence that you would have erected it, starting with sag angles, then roof purlins, and then one portal at a time, leaving the bracing bay till the end. And we really had to put a lot of thought into our sequencing and the method statement in dismantling this building. So we did that. After that, we had to clean all the steel, steam cleaned all the steel that it's nice and clean. It's galvanized steel, so it didn't need to be recoated or anything. Moved it with trucks to the new site where we erected the building again. And so from a health and safety side, we were quite successful with this. The mine actually gave our people an incentive that if we dismantled the building without any health and safety incidents, they gave them an incentive, and at the same time, if we erected the entire building without a single incident, they gave them an incentive, and both times we successfully accomplished that. It just shows you that even our mining industry is not full of, there's not a lot of money going around. So the fact that they decided to move the building instead of build a new one really shows that it's the financial stress that everybody in our country is having. But the fact that the building is built out of steel, you could accomplish just that. Literally move the building when you finished. And that's what I understood from them, because we're building another one now where we've built a new building. But those mines only work there for 10 years, and then they finish mining the area. So you'll have all this infrastructure doing nothing there when they move on. But in this way, they dismantle the buildings, go to a new site, and just re-erect it again. The benefit is the fact that it can be erected. So it's a bolted structure together, no matter how big the building is. And it could be dismantled and moved somewhere else and put up again for exactly the same purpose. There's a lot of cost that went into the relocation of the building, but still not near the amount of cost that would have cost the client to build a whole new building and have another structure standing somewhere redundant. So it could only have been done with steel. Our whole company, if you had to ask anybody, we are most proud of the fact that it was accomplished. When we got onto the site, people working for the mine actually laughed and said, "Are you the guys that are coming to move this building?" Because it had been something on the card for so long, and everybody shying away from the challenge of moving this building within the health and safety of the mine. So we are very proud that we were able to stand up to the challenge, go in there, take off the sheeting, dismantle the building, move it and re-erect it without a single incident, not even the smallest of health and safety incidents. Everything just went the way it should. And I think it's quite an accomplishment to do that in the mining health and safety environment. The planning phase of actually starting the project over and having workshop drawings drawn up was really did everything for us, because it was used for health and safety, it was used for the method statements, laying it out for the engineers to understand how we're going to do it. The Tekla model was used for all of these things, even where our cranes would stand to do certain things. So really handling the project with a drawing and a model from day one is really what made the success.